Welcome back. Okay, I think my title this time is correct, the ambiguous case. So this, as I said, can have 0, 1, or 2 solutions. Can have 0, 1, or 2 solutions. So let's do an example. Let's say that a lot of times they don't give you a sketch of the triangle. Actually, if they did, you could tell if there's 0, 1, or 2 solutions, because you could see if it was one triangle or if it didn't make a triangle. So they're going to always give it to you this way. One thing you can tell is I have a known column, right? You have a known column with your your C's there. And really, I would not worry about, I'll kind of show you. When you're finding an unknown angle using law of sines, you need to be concerned there could be 0 or 2 solutions, or 1, of course. So this is going to be one of those cases. This is where we're finding the unknown angle. So we say, oh, we got this law of sines. I have a known column, the C known column. But this is a bit bizarre. We haven't seen this yet. I'm going to do this. Okay, we got this. Cross multiply, 46, sine 31 equals 29 sine B. Divide both sides by 29. Let's switch this order here. And you better get a number less than 1. And this time, you get 0.8170. That's rounded to 4 decimal places. If you didn't get a number less than 1, think about that. And we will come back to that later. But or you could ask your calculator, and it knows. So I put this in my calculator. Remember how you do this? You do, I guess I'll just show you. You do second sine of second answer. Don't type in this number. Do second answer. Second answer. And you're going to get 54.78 degrees. Okay? And here's the tricky part. What did we just do? Well, we just asked the calculator this. We said, calculator, tell me, when does a sine curve, which goes on and on and on, when does a sine curve become 0.810? Well, that's about here, right? And it hits it there, and hits it around here, and hits around here, and hits around here, and hits around there, and hits around here. There's an infinite number of answers. How could they give us this one answer? Well, because we did arc sine, and arc sine, the whole restricted domain, all that stuff, is always going to give you something from negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. So if it's positive, it's going to give us this first quadrant answer. In this case, it's about 54.78 degrees. But how do you know it's right? How do you know it's not? Well, of course, we know it's not negative. These are absurd, right? You can't have negative angles in a triangle. We know it's not going to be something up here, like bigger than 360 degrees. Those are absurd. No. But what about this one? That one is possible. This right here is pi or 180 degrees. That's just like an obtuse angle. If you look back up here, oh, I saw on the previous page, it could be acute or obtuse. This one right here is assuming acute. But is this possible? Yes, it is. How do you get that angle? Well, remember, these two angles here are, there's symmetry. They're supplementary to one another, these two right here. So I'm going to write another angle, another answer, which is a supplement to this. Luckily, I wrote this down in advance. It's 125.22 degrees. What am I doing here? Hang on a second. I got 2 degree symbols. There we go. Okay, 125.22 degrees. And again, I got that because I did 180 minus that 54.78. So these are both possible answers for B. And this is really hard to teach in this format. This is the thing that makes this section hard. This is going to have 2 solutions. I can tell right away, because what you're going to do is think, this angle here, is it possible to have a triangle with a 125.22 degree angle? Yes. But the key thing you have to look at is this angle up here. You see what I'm looking at? Was that a 30? That's a 31, by the way. Can you have a 125, can 31 degrees and 125.22 degrees, let's write this, can coexist? Yes, because they add to be less than 180, so they can coexist. That's fine. So that's an indication we're going to have two solutions on our hands. You know, I wish I'd written equals b. And let's box our answers. We're going to have two solution sets. So I want you to put a vertical line here and show me your two solution sets. So one solution set, and what I would do on your calculator is, I should have said this earlier, but this number right here, I guess you can do this once this is on your calculator now, but you want to stow this in your calculator. I'm just going to put this store in, that's a store in calculator. So you could hit, you know, the stow button and X or B if you want to use that. And you'll see why later. I always find this solution next, and then I come back over and find this solution that goes with this one. There's two solutions. Even though we're going to have 6 boxed answers, but there'll be 2 solutions with 3 boxed answers each. Okay, so if B is that, we can quickly find A, because if you go back up to here again, a triangle that has 31 and 125.22, the other one would be 23.78, because they have to all add to 180. And then finally, to get my last thing, which is, what is it, side B? I got that. Last thing is side A, that's right. Because we have side B, we have side C. Okay, so the last thing to do is get side A. And our known column, use your same known column. You're going to use it 3 times. Sine of 31 degrees over 29 equals sine of this new 23.78. Stow that in. Use second answer over A. And I'll let you do that, but you're going to get, you should get exactly, oh, I can hardly read this, 22.71. Let me know if I'm wrong about that. Over here, now you come over here, you come up here, and this is where it's nice if you stowed this number in, because you have the exact, 54.78 is not exactly right. A does turn to be 94.22, box that. Use the sine 31 over 21 known column, or is that 29? 29 known column for the last time. Equals sine of, we'll put in that 94.22. Actually, we're putting in the second answer over A, and this one should be 56.15. Box it. So you see the 6 boxed answers. You have 2 solutions, 1, 2. Looking at the left solution, we can see that angle A is obtuse, right? So the side A must be the biggest, 56.15. Yes. Looking at the other one, angle B is obtuse. So both these are obtuse triangles. That's interesting. So B should be the largest. It was 46. Is that bigger than the others? Yes. And A is the smallest angle, so little a should be the smallest? Yes. So there's some things you can do to check your work. Okay, I think we're only about 9 minutes in. I'm going to try to knock out 2 more quick ones. That's the long one. So with 2 solutions, they are long. So hang in there. That's a long one. Let's do a new example. Let's say you're given that A is 98 degrees, little a is 10, B is 3. Now I can tell right away that this can't have 2 solutions. I'll tell you why. Or you can think about, how would I know? Right away we see we got our known column. So we're going to get really used to looking for that. That's a 10. Equals sine of the unknown B over 3. We cross multiply. I'm just going to jump to the last part. Sine of b, check me on this if you want. Sine of b is 0.2971. Hey, 2971. Which tells me that b is 17.28. Go ahead and box your answer. Let's store it in our calculator. Stow. But then we need to also find the other possible value for b. It is 162.72. Remember how we're getting that? 180 minus 17.28. But how do I know this angle is not possible? It's quite big, right? But it has to coexist with this angle. That's not possible. You can have a triangle with a 98-degree angle and a 162-degree angle. Not happening. So this one is not. We're only going to have one solution. So how did I know from the beginning? This number, if it's obtuse, you're going to have no more than one solution. Because the whole reason you get 2 is because you say, I don't know, it's acute. It could be obtuse. Well, if your beginning angle is obtuse, you can't have another angle that's obtuse. You can know that or not. If you don't know it, you'll figure it out as you're doing the problems. So this is great news. We don't have to do this twice. We can immediately find angle C. Let's get back to that blue, or let's get to blue. Angle C, we immediately can find because they have to all add to 180, and in this one it is 64.72 degrees. Box that. We use our same known column one more time. Sine of that 64.72. Again, in your calculator, use second answer over your unknown C. And you can check me on this. C should be 9.13. And there's our 3 boxed answers, 1 solution. So what you do is assume 2 solutions until proven otherwise. We only had 1 solution. So because this was not possible. So what does the 0 solution look like? These are the shortest of all. I think we can do this in about 2 minutes. So let's say A is 62 degrees. So far, harmless, right? Looks like it would work. A is 10. B is 12. You would never notice that something as innocent looking as this would have no solution. Let's see. Known column, yes, let's do it. But how would I know it has no solution? Well, you do the process, and I'll just tell you sine B turns out to be 1.0595. I think we mentioned this earlier. It has to be less than 1. What it's saying is this. It's saying, hey, sine, tell me what angle are you when you're 1.0595? Never. Remember, sine never gets above 1. Never. So when you get here, you say no solution. Now you want to give yourself some justification, and I think this right here is enough justification. You could say because sine of b, I guess seen this before, can't be greater than 1. Or say can't be greater than, yeah, that'd be fine. Can't be greater than 1. But I would like to say, I would like to see that. That's kind of your proof. There's not much work on these, but that would be a good thing to show. Okay, that's probably enough for this video. I got one little tiny one, probably like a 7 or 8 minute one left.